When you strip away all the complexity, all the jargon, programming really comes down to a simple question. How do you give a computer a to-do list? Seriously, that's it. It's not magic. It's just you have to write that list in a language the computer actually understands. And today, we're going to tackle that by looking at one of the most powerful languages out there, C++. The plan is to break down the absolute basics, the fundamental grammar, so you can start writing your own to-do lists for the computer. So, just like learning any new language, you gotta start with the vocabulary. You need the basic words. And in the world of code, our most basic words are the places we store information. And the most fundamental concept here is the variable. Honestly, the best way to think about it is just as a box. That's it, a simple box. You slap a label on it, and then you can put stuff inside. A number, some text, whatever. It's just how a program remembers things. And check out how easy it is to make one of these boxes in C++. If you want a box that's specifically designed to hold a whole number, you just type int, which is short for integer, and then you give your box a name. Here we're calling it age. And that's it. You've literally just told the computer, hey, set aside a box for me, label it age, and I'm going to put a whole number in there later. Okay, so we've got our boxes ready to store stuff, but how do we actually get information into them from user? And how do we peek inside to see what's there? Well, we need to have a conversation with the computer. To get the computer to show us something, to talk to us, we use this little command, cout. You can just think of it as cout, and you pair it with these two angle brackets, cout. See how they're pointing away from the command? They're literally showing the direction the information is flowing, out to the screen. Yeah, this visual nails it. You're taking some piece of data from your program, and you are inserting it into the stream of information that's heading right for the user's monitor. Cout and C++ arrow squeeze, that's your computer's voice. All right, so what about the other side of the conversation? Listening. To get info from the user, we use CIN, or character input. And notice what happened to the operator. It flipped. Now the arrows are pointing in. And again, the arrows tell the whole story, don't they? They're pointing away from the keyboard and into our program. It's a really clever visual way to think about it. CIN and double dash work together to extract whatever the user types and stick it right into one of our variable boxes. Okay, so we can store data and we can talk to the user. Now it's time for the fun part. Let's add some action. We need the verbs of programming to actually do things with our data. And that is where operators come in. And here they are, the basic toolkit. You've got your usual suspects: plus, minus, multiply, divide. But take a look at that last one, the percent sign. That's the modulus operator. All it does is give you the remainder after division. So like 20 modulus 3 would be 2. Why? Because 3 goes into 26 times with 2 left over. Trust me, it seems weird, but it is incredibly useful. Now have a look at this. When a person writes out a formula, it can be, well, a bit of a mess. There are fractions, some of the multiplication is just implied. It's really easy for us to misread it. And that kind of ambiguity is a computer's worst nightmare. But then, look what happens when we translate that same formula into C++ code. Every single step is perfectly clear. There is zero ambiguity. That's because C++ has a strict order of operations, just like PEMDAS from school. It knows exactly what to do first, second, third. It's the perfect, unmistakable to-do list. So being super clear is job number 1. But programmers also really value being concise. We love a good shortcut. Now that you've got the basic vocabulary down, let's learn a little bit of the slang, the clever tricks that make code just a little bit cleaner. It's super common to need to update a variable. Take its current value and add 5 to it. You could write it the long way, x equals x plus 5. But C++ gives us this neat little shortcut, x plus equals 5. It means the exact same thing, it's just shorter to type. And this works for all the basic math operators. It's a nice little pro tip. But with programming, the tiniest changes can have massive effects. So, pop quiz time. Let's say we have a variable val, and we set it to 10, then we calculate a result by multiplying 10 by val plus plus. What's the final value of result going to be? Think about it for a second. That plus plus is the key. Okay, you got it? The answer is 100. But val itself actually becomes 11. Now why? Because the plus plus comes after the variable. The computer uses val's current value, which is 10, for the multiplication first. So result is 10 times 10. Then, after that's done, val gets bumped up to 11. It's all about the timing. All right, ready for round two? Same setup, but with one tiny, tiny change. What if we move the plus plus so it's before the variable? So now it's plus plus val. What's the result this time? And there it is, 110. Totally different. This is called pre-increment. The computer increments val to 11 first, and then it uses that brand new value in the calculation. So result becomes 10 times 11. See? A tiny change in the code, a completely different outcome. Precision matters. All right, let's just take a step back for a second. We have covered a lot of ground here, from making boxes to store data, to doing math, and even a few tricky shortcuts. Let's see how all these little building blocks actually snap together. It really just boils down to this simple three-step pattern. First, you set up your storage, your variable boxes. Second, you have a conversation, either getting information with SYN or displaying it with COUT. And third, you tell the computer what to do with all that info, using operators. That's the fundamental loop of so much programming. And believe it or not, with just those few simple ideas, you've already grasped the basic grammar of C++. You get the nouns, which are the variables, you get the verbs, which are the operators, and you get how to structure a basic sentence. So, I'll leave you with a final thought, a little puzzle to chew on. Using only the tools we've just talked about, variables, input/output, and those basic math operators, how would you tackle this? How would you write a to-do list that makes the computer take the number 1234 and spit out 4321? I'll even give you a hint. Remember that modulus operator we talked about, the one that gives you the remainder? It's really good at picking off the very last digit of a number. The tools are all there.